Next, let's do example 10, which is on page 843. Now, before we do example 10, I guess this is a good time to tell you this information. That is tangent theta. We have, let's say, this thing here. Okay, this is theta. Tangent theta is equal to opposite. We'll call this y. Okay, this distance is y divided by the adjacent, which is x. Now, y divided by x is called tangent theta, as we have learned at some point in this chapter. But it is also equal to the slope. Okay, that was taught in algebra. Because what is the slope? The slope of a slanted thing like this is calculated by the rise divided by the run. So this is also, a slope is always called m. So the tangent theta of some slanted thing, what is this called? I don't know. But anyway, is actually the same as the tangent of the angle that this plank makes with the ground. So remember, tangent theta equals to m being the slope. And that's always the case. Now, knowing that, then now we are ready to do example 10. Example 10 says we have two intersecting lines, and then theta is the angle between them. Show tangent theta equals to those equations. Okay, so let's look at the next page to see what they mean. What they mean is that we have two lines. I'll draw it like they draw it. We have L1. Okay, this is the first line, and then L2. This is the second line, and they make various angles with the ground. This is theta 1, and this is theta 2. Now L1, wait a second. L1 is, okay, and no, I wrote it wrong. See, I knew that was different. Let me fix it. Okay, now this is L1, and this is L2. That's better. Okay, L1 makes the angle theta 1, and L2 makes the angle theta 2. So then, as a result, well, my L1's a bit too, let me fix this picture. All right, I have drawn this again. This look a little better. Okay, so this is the angle theta 1, and that's theta 2. And the angle, this angle here is theta, the way your book has it. And that angle is the same as this angle from geometry. Okay, this is theta. So we have three thetas: theta, theta 1, and theta 2. All right, and specifically, there is, being that this is theta, we know that from, what are we looking for? We're looking for the formula for theta. So we're looking for that thing. Now from geometry, you might remember, if you have taken it, is that A, this angle out here equals to the opposite two angles. If this is a triangle, then A equals to B plus C. That's a fact from geometry. The reason is because the three angles in here add up to be 180 degrees, and so does A add up to be this angle. That's why A end up being equal to C plus B. If you haven't taken geometry, just memorize this fact for now, and please take geometry when you have time. I haven't taught geometry yet, but I'm planning on doing it. Okay, and geometry is one of my favorite subjects, favorite math subjects in school. It's a lot more exciting than a lot of algebra, because geometry doesn't have much grunt work. It's all fun stuff in geometry. So anyway, so remember, A, that is, this angle is equal to B plus C. In other words, theta 1 is equal to theta 2 plus theta. I'll write that down right here. Theta 1 equals to theta 2 and plus theta. And put it another way, since we're looking for theta, well, theta equals to theta 1 minus theta 2. Okay, this is theta. Now, now that we know this, the next thing we remember is that tangent theta is equal to the slope of the line. Okay, each line make a certain slope, would make a certain angle with the ground, the horizontal x-axis, and its slope is called tangent of theta. So L1, the slope of L1 and is we'll call it M1. Okay, slope of L1 will be called M1 is equal to tangent of theta 1. There's L1 here. Similarly, the slope of the second line L2 M2 equals to tangent of theta 2. So then the what are we looking for? Tangent theta. So tangent theta is then equal to theta 1 minus theta 2 is equal to tangent of theta 1 minus theta 2, being that theta 1 and theta 1 minus theta 2 equals to theta. Okay, and then which following the tangent rules. What are the tangent rules? I have it right here, and here we go. Let me do something here. Now I have copied down the screenshot from the book. The tangent of, what are we doing here? Tangent of theta 1 minus theta 2. Okay, now we'll write down this formula. That's a tangent subtraction. That equals the tangent alpha minus tangent beta. The first one so the minus sign stays on top, and the bottom is a plus sign. So let's do that. So that equals to the minus sign. That equals to tangent of theta 1. Okay, minus tangent of theta 2 divided by, and the bottom is plus 1 plus tangent theta 1 and times tangent theta 2. And that equals to tangent theta 1 is M1, as we have mentioned before. So this equals to M1 minus M2, which is tangent theta 2, such right here, divided by 1 plus tangent theta 1 is M1 times M2, which is tangent theta 2. And that is the equation for tangent theta. As you can see in that's what we were trying to prove. And oops, that thing blinked out. Try again. All right, so that is exactly what the book wants us to prove. Okay, and the main part is you just have to know that tangent theta equals to the slope. Okay? This is something that's quite important, and the book didn't really openly say this so much, but that is what they mean at the bottom. That tangent theta 1 equals to M1. Why is it equal? Because the slope is opposite divided by the rise over run, okay, which is just opposite divided by adjacent side. So they are exactly the same thing. So with that, let's look on the next page, which 844, where we consider problem example 11 after I clean off the board. So next, let's look at problem 11 on page 844. Let's read this thing, okay? There is for some wall, a wire R is attached 47 feet high, okay? So that's the top wire. And next, there's another wire that's 40 feet high. So we have two wires. All right, so let's draw a rough graph of this situation. We have two wires. One is somewhat lower, and the other one's somewhat higher. So we have two wires. One is at 40 feet, and the other one is at 47 feet. Okay, so this whole thing is 47. All right, so that is that. And then the distance on the ground is 50 feet. The question is, what is the angle between the wires? So there's an angle, this little angle right here, we'll call it alpha. The angle in between, we want to figure out what that is. That should be simple enough. The angle right here, the first part of this angle, we'll call it angle A, okay? And angle A is equal to the tangent inverse of 40 over 50, because tangent of A is opposite over adjacent, which is 40 over 50. So to find out what A is, we just plug this right in, okay? And that will give us A. Now, the next question is, what is this whole thing? We'll call it B, okay? The whole angle from the ground to the top wire, we'll call it B. B would be tangent inverse of the whole thing, which the height is 47 over 50. So that would be B. Now, therefore, what is alpha? Then alpha is clearly equals to B minus A. That's all, right? Alpha equals to B minus A, so we're going to do that. We're going to plug all that into the calculator, and that should get us the answer in no time. Let's see. Can you read the board this way? Looks okay. Yeah. So why don't you read the board, and while I hold the calculator in such a way as to not block that view. Okay. So actually, I don't think I can do that. I think I'll stand on this side. That might be, yeah, that's better. So anyway, we'll type in tangent inverse. So shift tangent. Where's tangent? Sine, cosine, tangent. Okay. Then type in 40 divided by 50, close parentheses, like that. And then minus again, shift tangent. That gives the inverse tangent of 47 divided by 50. And close parentheses. Okay, that looks okay. That should do it. Push and turn tangent inverse. Oh no, I'm so sorry. I was supposed to do B minus A. I typed in A minus B, didn't I? So that is wrong. But we can probably edit it. So see, I'll go to the 40 point. Okay, so actually I'll hold it this way, it's easier. Let's see, we'll just delete that 40, that change it to 47, and then move a little more. And then this one, we'll delete it and turn it into 40. So that should do it. Okay, that is in radian. We need to change it into degrees. How did I do the degree thing? I forgot. I think it's shift setup or something, and then 3. Yeah, 3 for degrees. Okay, so push it again. Now it's 4.56. Okay, and so I got 4.56 as the angle in between those, the tiny little angle between them. Is that right? Flip to the next page. Yeah, that is correct. See, the next page says so right here. Now the book also used the sum or difference formula. Let's not do that. Okay. I mean, why do we want to do all that work? I mean, look how much work the book did. And well, let's not do work that we don't have to do, because that doesn't make any sense. That's not what math is about, okay? And see right here, there's instead of doing what I did, the book plugged in the tangent difference formula, which is, and then on the next page, there's more stuff, right? There's a ton of, right? You have to write a ton of stuff. When all we have to do is just do B minus A and make sure you don't mess up like I did and subtracted the wrong direction. And then of course it has to be in degrees, because this problem happened to care about degrees. But other than that is well, anyway, that's that. So that is the end of this section. For homework on page 845, please do problems 11, 15, 17, 19, 21, 27, 31, 37, 47, 49, 50, and 51. And when you're done, I want to talk about 2 of them. Okay, now that you're done with the homework, let's consider problem number 50 on page 847. Which is cosine x plus y times cosine of x minus y, and we need to prove that it equals to cosine squared x minus sine squared y. In other words, we need to work on one side and beat it around and stir it and stuff until it looks exactly like this side. So that's what we're gonna do, and we're gonna do it by whatever this section says, okay? Which is what we learned here is just this part, we'll look at the cosine formulas. That is cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Cosine alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. So the signs are opposite, okay? The minus got transformed to plus, and plus is got turned into minus. And then there's the cosines in front, and then the signs are on the back. Well, that's sort of how you can help memorize it. But anyway, so that is the formula we're going to go by. And we're going to write all this stuff out. And then, okay, so let's start writing. So cosine of x plus y is equal to cosine x cosine y minus sine of x and then sine of y. And that is just this part, okay? This is cosine x plus y. This will be multiplied by this part, which is the plus 1 turned into minus, okay? And then the next part, the minus 1 is going to turn into plus, all right? So that becomes cosine x, cosine y, and then, let's see, plus sine x, sine y. All right, that seems to be a lot of stuff, which it is. But notice that these are the same. This is the same thing, okay? That in other words, this part is the same as this part. This is both cosine x, cosine y. And then the other part here, which okay, this part is identical to this part. All right, so being that they are the same, that would mean one thing. That would mean we can use the difference of squares formula. Let me see. I need to put that down. All right, so the difference of squares says that a minus b times a plus b equals to a squared minus b squared. So this part equals to cosine x squared, cosine y squared. Now, remember this square means the whole entire cosine x got squared. And same with the cosine y. Minus sine squared x, sine squared y. So that is that should be good, okay? And then what are we supposed to do again? Let me see. Square cosine y, okay. The next part we're going to do is, let me think. Okay, so what we're going to do is we're going to turn everything, here's the answer, where's the answer? We'll turn everything so that it becomes cosine squared x and minus sine squared y. So we'll keep the cosine squared x, and then we're going to turn cosine squared y into something else. This will become cosine squared y is 1 minus cosine squared x. Is from the Pythagoras theorem, which says that 1 minus cosine, put this over there, okay? Cosine squared is equal to sine squared. Why do I have cosine here? I mean sine squared. 1 minus sine squared equals to cosine squared. Yeah. And it's y, not x. There, that's better. We have sine squared y. See, 1 minus sine squared y will be cosine squared y, according to this principle here. Now continuing, and we need to keep the sine squared y right here, okay? So we'll get rid of this. Getting rid of that, sine squared x is 1 minus cosine squared x. Again, from this principle. So we're keeping the sine squared y. And at this point, then we have the cosine squared x is equal to cosine squared x, okay? And then this is the minus cosine squared x, and then sine squared y. And then over here, we have minus sine squared y, okay? 1 times sine squared y, and there's a minus sign. So we have minus sine squared sine squared y. And then this multiplied together becomes plus cosine squared x times the sine squared y. So there is a, so as you notice, there is a minus cosine squared x sine squared y, and then there's a plus of the exact same thing. So these two things cancel out, and we're left with this, which is exactly what we're shooting for. So that is how we do problem 50. Okay, so next, after I clean off the board. Okay, so next let's do problem 51, where we're supposed to prove cosine of x plus h minus cosine x divided by h. It will be equal to this stuff right here, cosine x times cosine h minus 1 divided by h, and then minus sine x, and then sine h divided by h. You might wonder why we having h here. It's just the book wants to call it h, so we'll call it h. Doesn't matter what you call it, okay? As Shakespeare says, a rose by any other name is just as sweet. So call it anything you want. But just remember, these are two different variables, okay? This is x, and the other one is h. And with that in mind, we are going to apply our cosine formula that we just looked at, in fact. But we'll look at it again. What are we looking at? X plus h. So we're looking at the plus version. Okay? And the plus version, cosine alpha plus beta, is cosine alpha cosine beta minus sine alpha sine beta. So we'll copy that down, okay? And make this look like that. We'll do that. And so first, let's work on the cosine thing, which is so cosine of x plus h, by applying the cosine formula, is equal to cosine of x cosine of h minus, okay, that's a plus formula, becomes minus, minus sine x and then sine of h. So x and h will be the two angles in here instead of alpha and beta. Okay, that should do it. So putting that there. So this part is just the cosine of x plus h. And then we'll minus cosine x, minus cosine x right here. And then the whole thing will be divided by h. Divided by h. I will, okay, write h right there. Now we have to make this fraction look more this way, okay? That is the goal. Let's see. And to do that, we will we have the cosine x right here, and then there's a cosine h right here, and then h is being subtracted by something. Let's see, sine h, and there's another cosine x. Okay, let's rewrite this. Right. We'll write this thing over here. Okay, so I'll write another line. All right, so I rewrote this fraction, and by moving the cosine x closer here to be closer to be this cosine x, and then it's divided by h. I also broke down the fraction into two pieces. So cosine x got moved over here. So now we have the cosine x cosine h right here, and then minus the cosine x is up here, and then what's left is the minus sine x sine h, and it's divided by its own fraction over there. So I broke the fraction into two fractions. So and that is looking pretty good, okay? And so now all we need to do is factor out the cosine x right here, and then we are home free. So let's see, we have cosine x factoring divided times so what's left is cosine h minus, that's just 1, okay, divided by h down here, there's the h, and then minus over here is the same thing here, see, and we don't have to so it's sine x and then sine h divided by h. We'll write the h under sine h because that's how the book wants it written. Okay, so we'll write it exactly like the way they want the answer to be. And with that, that is it. We have finished problem 51, and that also marks the end of this section.